Okay, guys, so let's finish up these improper integrals so you get a better idea of how they actually work. So let's do just a bunch of examples here. And remember that what makes them improper is that they have infinity up in as one of the bounds of integration. Okay, so we see something like that, and we know we're going to put a b in. So we're going to go the limit as b heads to infinity from 0 to b, e to the negative x dx. Okay, now we're going to go ahead and take the integral. So I'm going to still write down limit as b approaches infinity. The integral is negative e to the negative x, and I have to evaluate that at b and at 0. So I'm going to make sure I do this part first, and then I'm going to find the limit. Okay, so I have the limit as b approaches infinity, and that is a negative e to the negative b minus negative e, so that's going to become plus, to the 0. Okay, so now remember that we want to get this in a form that's a little bit more friendly. So anytime I see a negative exponent, I'm always going to move that. I don't know, my brain just works better with it that way. So I'm going to say that this is negative 1 over e to the b plus 1. Okay, now I'm going to take the limit. Okay, so if I put infinity in there, that's going to make this thing go to 0. So plus 1 is 1. And then we say that if you get an answer for your integral, that tells us that the interval converges, or the integral, I should say, converges. It approaches a number. Okay? And we usually want to write that anytime that we work with these. Okay, so you show what it's equal to, and you talk about that it converged. Okay, let's look at if we had negative infinity to 0, x e to the x dx. Okay. Now, this is one we haven't done for a while here, because this one has a product, right? And so we didn't have, we had like the product rule for derivatives, but let's look at what we had for integrals. So I'm looking in the little yellow sheet because I didn't look in here, to see if they give it to us on here. It's probably in here, and I just don't know where it's at. Okay, so this, remember, if we have two things multiplied, we could try a u substitution, but it's not going to work. So I'm going to do integration by parts. And remember that that's when we did the u, v, v, dv. So we call this part right here, that's going to be u. And this part right here is going to be dv. Okay, and then we said, all right, then du would just be 1, and v would just be e to the x. Okay, so if you forgot how to do that, which I wouldn't blame you, go back and look up that with our integrals. Okay, so now I'm going to go ahead and I'm going to rewrite this. The limit as b approaches negative infinity. And actually, I think I'm going to call it a. Let's make it an a. Okay, so I'm going to put down here a to 0. Okay, oops, wait a second. I got to do my integration by parts. So I got to do my ultraviolet voodoo. Okay, ultraviolet, that's going to be x e to the x minus, and now I'm going to put a to the 0, and it's voodoo, e to the x dx. Okay, so again, this is going to be the very last thing. Okay, so I'm going to go x e to the x. the integral of that is e to the x, and then I'm going to go a to 0. And remember that we plug in this whole thing gets a to the 0. Okay, and I'm going to do that first. Okay, so I'm going to have the limit of x, so that is 0 times e to the 0 minus e to the 0 minus, now I'm going to do this one, a e to the a minus e to the a. And again, that has the whole limit thing on there. Okay. Phew. This has got a lot going on here. Okay, so let's see. Well, this is going to be 0, right? That's gone. This will be negative 1 minus a e to the a plus e to the a. Okay. Now, so we're getting a twofer here, you guys. Not only are you getting improper integrals, but you're also getting a review of integration by parts. Okay, so this will equal negative 1 minus negative infinity times e to the negative infinity plus e to the negative infinity. Okay, so let's watch how I'm going to write this. So I'm going to say this is negative 1 plus infinity over e to the infinity, because I got to get rid of that negative, plus 1 over e to infinity. Okay, so here, this is going to equal 0. But this one is infinity over infinity. So that one's not going to cancel out. But there's kind of a nice little trick for this one. So watch how I'm going to write this. So I'm going to go negative 1, and I'm just going to write this as infinity times 1 over e to the infinity. Okay, so now, kind of nice little tricky. That is 0. Infinity times 0 is infinity. So this is equal to negative 1, and we're going to say the integral converges. Okay, so that one kind of had, a lot of little stuff in there that we went over besides just improper integrals. Okay, so let's look at another type of improper integrals, and we're just going to call this type 2. And all we're going to say is that if you have infinity in both of the bounds. So let's say we want to go from negative infinity to infinity of 1 over x squared plus 1 dx. Now, when you see two infinities, some people will write this as two integrals, and at first, before they do the whole limit thing, they'll go, I'm going to go from negative infinity to 0, and then they write another one of 0 to infinity, and then they put a's and b's. I just prefer just to keep it as 1 right here. Okay, so I'm going to rewrite this as the limit as b heads towards infinity, and we're going to go from negative b to b of 1 over x squared plus 1 dx. Okay, so now I also kind of tried to put in some of these that we practice, things that I want you to remember. Okay, so this is one of those special forms. That's the inverse tangent right there. Okay, so this is the limit as b approaches infinity of the inverse tan of x. Oops, what am I doing with a dx? I don't need a dx. I need to go from b to negative b. Okay, so now I'm going to do the limit as b approaches. I keep writing that as an 8. So yeah, I'm experimenting with how I'm writing my infinity. Okay, so this is tan negative 1 of b minus tan, or inverse tan, I should say, of negative b. Okay, so now I'm going to put in these infinities. And remember when we said that when we do inverse tan, remember how we said that it goes, this is pi over 2, and this is negative pi over 2? Okay, so when I plug in infinity in here, so arctan, inverse tan, whatever you want to call it, okay, so it's going to look like that. Okay, so as we go out to infinity, the arctan heads to pi over 2. Minus, as we go to negative infinity, it goes to negative pi over 2. So a minus and a minus. So we're going to get pi over 2 plus pi over 2 equals pi. Okay, so we're going to say the integral converges. Don't worry, we'll get one that doesn't. And I think this graph, if you look at it, I think this is the one. I think it looks something sort of like this. And so what we just found out is that the area under this thing is pi. And it'll never get any bigger than pi. Okay, now let's look at type 3. Let me see how long our video is. I probably have to add in another video. So I'll see you in a minute on the next video.